Hi folks, I thought it might be of interest to, well, probably only to Hudson owners of this era of vehicle, to see inside, if they haven't actually had to do this operation, the inside of the hubs, and particularly with the half shaft taken out. It's a Timken axle, very well known, fitted to many cars of the era, and the bearing runs partly on this cone, which is within this adjuster, which can be screwed in to tighten the bearing. Now what it does effectively is tighten it by putting pressure on the cone which is fitted, the inner cone which is fitted to the half shaft. It transmits the force to the other side so that the similar adjustments on the other side takes the force, and that's how you take up the slack and determine the end float. And then as a locking pin comes down, which you can set the thing at, I think it's 22.5-degree intervals, until you've got the appropriate amount of end float, which is between 5 and 10 thousandths of an inch per the book anyway. It'll get away with more. Doesn't want to be much tighter. I think there's a danger, I suppose, if things heat up, maybe there'll be undue pressure on the bearings. What you're seeing in there is a felt oil seal, and there's another one further along, and then there's a greaser that introduces grease. But quite honestly, the greasing of these bearings isn't really necessary once they're pre-packed. I find that greasers tend to just flood bearings with grease, and you think you're doing good to bearings with rolling elements by continually greasing them. Well, I have it on very good engineering authority that initial filling of grease, as you get with sealed bearings, is quite sufficient for their service life, and that further greasing risks putting the wrong grease in, too much grease, causing it to the rollers or balls to plow through it, liquefies it and undoes the job, and actually reduces bearing life very drastically. So no, don't keep greasing these. You think you're doing good, but you're not. So why this half shaft is out is because the tapered end onto which the hub fits, and therefore determines the position of the hub, but it also determines the position of the brake drum. The brake drum was actually colliding with this support bracket and starting to grind with it. So we have to find a way of setting the whole hub assembly, when tightened up, further out. And it's a feature of this type of axle, a semi-floating axle with this form of adjustment, that the half shafts have hardened buttons on the end. It just so happens that with this car came this extraordinary creation, which is pieces of flat bar welded together to form a hex, and welded to an old cut half shaft. This is actually came with the car in order to undo the brass center locking hubs, but it retains the inner portion which goes into the diff, and here we have the hardened button or wear pad or whatever you would call it, which abuts the other shaft going out to the other hub. And this transmits the force I spoke earlier about. When you're cornering, it takes the load to the opposite side and so on, and it determines the relative clearance of the bearings right across the axle. So what we're going to do is build up this hardened face. These are actually plugs. They're inserted as plugs, and believe it'll come out for the purpose of building it up with very hard material and dressing it, grinding it down flush. The plan is to add about 3.5 millimeters, which will accommodate the degree to which the hub is sitting down on the taper due to wear and whatever, and a little bit extra for adjustment. And that'll mean then that the brake drum no longer collides with any of this support bracketry roundabout, and there'll be no grinding noises, and we'll feel a whole lot happier about it. So, and also I'm going to have made up another one of those EN1A hubs with the 1-inch square drive that was shown in a previous video. This is a right hand thread on this side, so it opposes again the direction of rotation, the normal direction of rotation of the wheel when the car's being driven forward. So, and sent a little locking wire onto a spoke. Feeling happier about that. This one wasn't too bad, but it wasn't brilliant either. And the other one's been such a success, and I feel I have a lot of confidence in it. Thought, right, that's one reason for doing it. But another compelling reason is that effectively it serves as a puller as well. We're going to devise a little center to screw in, to press against the end of the taper to extract the drum when required off the taper for the purposes of relining brakes or any attention to adjusting bearings. It don't really want to use a three-legged puller. It's onto cast iron outer parts of the hub. That risks danger, and I don't think it exerts the pressure in such a controlled manner as a threaded portion in the middle. And we only need to make one of those, and we can use it on either hub. It'll just go in the square center. So that's another little benefit, I think, of all this machining at this time. So this is probably intensely irrelevant to 99.99% of people who may come across this video, but it might be informative, or even a revelation, I should say, to anybody that's encountering problems where they've run out of adjustment and starting to hear grinding sounds with their 101-year-old Hudson, or indeed other cars like Studebakers, well, a miscellany of cars actually, which used essentially the same form of axle adjustment and brake setup. So that's all for now, folks. Thanks for watching.